Welcome, everybody. Tonight we're working on Unit 2. The topic is AI and technology, and really, more importantly, not just technology, but data. And I like to refer to it as disruptive technologies or revolutionary technologies that have come along. Of course, we're basing this all on the Intel AI for Workforce materials shared with us from Intel Corporation. This is our topic list for this class here tonight. So we're going to look at data and how it's collected, why it's important for AI, some of the limitations and usages of AI, and then how all these new emerging technologies are kind of really propelling this whole AI movement that we're going through right now. I always find it pretty interesting when we do these classes and we look at the materials that we're working with, how quickly they get dated. I think this slide shows probably about 2 years old now when it was last generated, and how much the material has changed even since then. There's a couple little quips they have in there that, like, by 2025 or 2026, and here we are, we're already at that point, and that's how quickly things move. Last week or 2 weeks ago, we did some introductory stuff on AI to get everybody grounded on, what it is and some of the important figures and how it developed over time. But now we start to look at data and information, and this is really a good segue from where we just came from, which was the Data Analytics 1 course. And we talk about this concept of what data is, and just to kind of underpin it and make it meaningful, right? Data is really a way to describe information. It can be numbers, it can be words, it can be symbols, it can be just about anything, truly. But data is just information, and information is important for doing any of the work that we do in this area. And we start off with this like really goofy question here, which is why was data collected ever? Like, why did people care enough to collect information? And we can go way back in history, and I think this is what's fascinating, because when we start to look at, what we have here is this clay tablet that comes from Sumeria, and the type of writing that's on there is called cuneiform. And the Sumerians were really prolific record keepers, and they use these like specialized tools to basically take a clay tablet, and they would make these marks in it. And this is kind of, this tablet here is a combination of kind of like language and numbers, and I can't really decipher it for you, but kind of an interesting thing to look at, because think about this historically. They wanted to record the information and not lose it, right? So how do we do that? Well, up until, I don't know, a few decades ago, we were basically doing that on paper. Here's a problem with paper, though. Paper, after a while, can degrade. It can fall apart. It can get moldy. It can catch on fire. It can, disintegrate to dust, right? Not a really good format for maintaining data for a long time. I don't know why they came up with this thought of, like, they would record the information on clay tablets, and not only that, they would harden the tablets. They would fire them so they basically became like stone. But strangely enough, even though this comes from 3000 BC, 5,000 years ago, the data persists, and we can read it today. And it was not always true that we could read these tablets. There was some pretty landmark work that was done about 100 years ago by historians, and they figured out how to read this form of communication, and therefore we're basically able to decipher much of the history of the Sumerian people from way back then. And they were one of those groups of people that really were prolific in a lot of different ways, like building their society, recording information, making buildings, significant advances in many different things. But the fact that they were smart enough to record their information in a way that would persist for thousands of years, they were pretty serious about their information. And I'll have you think about this. When we store stuff now, okay, maybe we don't put it on paper, but some of us do. We have some certain things that we store on paper, right? And we know that that paper is not going to last forever. So what do we do to store information long term, right? So like the ancient peoples figured out ways to do it. And often, and the information that persists is the stuff that was carved into stone. Like if you go to Egypt and you look at some of their ancient monuments, they're covered with hieroglyphs that tell the story of the king or the whoever was part of that building or whatever. And that's how we got to know a lot of them. Yes, they had things on paper too, but it's the things in stone that persist. They asked the question here, why was data collected and recorded? And they give examples here of like some of the challenges of storing information. It says, in order to store 175 million sets of fingerprints and 742 million tax returns on magnetic tape, right? The US government back in 1957 planned the world's first data center. And this is really kind of interesting. So they would take the information, put it into a computer, and then store it on a magnetic tape. And when we say magnetic tape, it's not like a cassette tape. It was literally like a big reel-to-reel tape, about a half inch or an inch thick. And they'd store the data on the tape, and then they'd take those tapes and they'd put it in a library of tapes. And it took days to put the information on the tape because the equipment was really slow back then. And then once they got it onto the tape only had a 10-year lifespan. And, even to this day, like anything that we have recorded on magnetic tape, cassette tapes, 8 tracks, reel to reels, whatever, they do not have an infinite shelf life. And it is a storage problem. Interestingly, even some of the modern things that we use to store information fail over time. Like if you store all your information on a hard drive, whether it's a spinning platter hard drive or an SSD, those also do not have a long shelf life. I have old hard drives that I saved from when I was running business operations, and I tried to access them a couple of years ago, plug them back in to see if the data was still there, and they wouldn't even spin anymore. So all the data is gone, right? And hard drives fail, and we think that they last forever. They do not. So like if you store your data electronically, like the big caution I give to everybody is every few years, make a fresh copy of that data onto a new hard drive or a new platform that will persist. We can also use optical discs like CDs, DVDs, Blu-rays, that format that can store a lot of information. They also have a limited shelf life. So this is really kind of an interesting challenge to society. We're generating all this data. How do we maintain it? And, and really, okay, why are we gathering all this data? Well, some of the things that we do, we use the data and predict weather. And it always amazes me. And I had a great example of it this weekend. I was looking at the weather forecast, and the National Weather Service was predicting that we would have a half inch of snow overnight, maybe an inch in some areas. I woke up in the morning to about 4 inches of snow, and I was like, how can their forecast be so wrong? And even, for example, so the data that they're using somehow was flawed, but all it takes is a little bit of a shift of an air pattern and you got more snow. They use the data for facial recognition. Very interesting. There are technologies like this. So like you can unlock your smartphone with your face, right? Some of us do that. You can walk into an airport, and if you're a terrorist and you're in the terrorist database, they probably have a picture of your face, and they scan at airports for people that are known terrorists. For real, they do this. The Wegmans food chain out east, they're kind of like the pick and save of the northeast part of the country, recently had an article put out about them that they are using facial recognition software on their customers, and they're matching up people's like frequent shopper cards with your face. And then if you're running their app in their store and you walk past a shelf with the thing that's on sale, it'll like vibrate your phone, and that's all based off of facial recognition. This is crazy stuff, but it's stuff that's happening today, and it's all driven by data, right? We also use data to understand language, to interpret what I'm saying and convert it into different languages. Or heck, the words I'm speaking now, when I publish this video, YouTube is going to recognize my voice, turn it into text, and then you can go to that video and download the text. And that's more data. Oh my God, right? So I better watch what I say for sure. So we use it for all those different types of things. So, I mean, they pose the question, what's changed from then to now? And really, it's all about how we store the information. There is a challenge if you want the legacy of your society to survive, is how do you take that data and put it into a format that will persist, right? And they show a bunch of different things. So we've had a lot of technological advancement. Doesn't mean the data persists any longer, right? So we have to come up with clever ways to do that. There's also this thing called the internet that happened, in the last, well, it really had happened at the very end of the 60s going into the 70s, but we didn't really call it the internet until we were well into the 80s. And it took until the mid to late 90s before people actually started adopting it. But very disruptive technology. It really, truly, if you think of the fact that the internet really didn't rise up until the mid 90s, here we are in 2026. And how could we operate without it? We wouldn't be able to shop. We wouldn't be able to bank. We wouldn't be, there's, holy cow, there's a lot of stuff we wouldn't be able to do without it. It really transformed our society. The other real big technological advancement was the move from desktops and laptop computers to smartphones. And everybody carries now a computer in their pocket and it's connected to the world, right? Very disruptive technology. And in fact, that technology probably rose faster than any of the others. It took the internet, not 30 years, but a good 20 years plus to really get to the point where it was used by normal people. Smartphones, oh my God, like the first day the first iPhone came out, man, there were lines around the block for people to buy them. Barely even had the networks to support them. And now everybody's got one in their pocket. Heck, our kids carry them around in their pockets, right? So they pose this question, do you think the purpose of collecting data has changed? This is really kind of an interesting thought. Like, what were those Sumerians carving on those tablets? They were keeping track of trade transactions. Well, we still do that, don't we? What other stuff do we keep data on? Well, just about anything you can think of is really kind of the answer. So this quote is a pretty profound one. I mentioned it in the last class a little bit, and they call information basically the oil of the 21st century, and analytics is the combustion engine. And this is the field that we're kind of moving into. And man, throw AI on top of that, and it's kind of like a nuclear bomb, the rate of growth of change. So information is really kind of what drives it all. They call data the fuel for AI, right? So why is data important for artificial intelligence? Well, artificial intelligence basically is built on machine learning models. Machine learning models are based on math and formulas. And in order to make those models work, we have to feed numbers into them. We have to take things in the real world, whether they're words or actions or regular numbers, and convert them into numbers if they're not. And then we use those to make decisions. And now that we have AI helping us, it's all accelerated to a ridiculous rate, right? And we have this like goofy little video of a robot, but for as goofy as that video is, that action that the robot is doing, I mean, how many of you, I'm sure I could do a backflip if I wanted, right? But to how did they train that robot to make that jump? I mean, it's impressive. I mean, I can barely jump. And now we got a robot not only jumping, but flipping over backwards and landing on its feet. What kind of data and information did it take to reach that point where it can do it on its own? I mean, think about that. It's pretty heavy stuff, right? There are some limitations, that we have to look at that are on the table, right? So let's kind of go through this list that they're going to bring us, right? Um, the concepts for AI, you guys learned this last time, right, have been around for a while. We just have not had the computing power to really execute it. It's the internet. It is, small form factor devices like smartphones, fast networks, big storage, data centers, faster computing power. All of those things have kind of added up to make it all of a sudden explode, right? Not like it wasn't possible before, but now it's much more possible because the technology has advanced so quickly. You know, so things that affect the growth of AI is data, because if I don't have data, I can't train my AI to learn and figure things out, right? So if we don't have data, we can't train AI models. One thing you're going to learn in these courses is that a lot of AI models, at least initially, were trained on public facing data. And we know the value of good information on the internet. The public facing stuff isn't all good. So that leads to biases, right? So that we have a problem. So, like, the issues that we have in society, I mean, just look at all the stuff going down in Minneapolis right now, right? Those issues are out there in the public. And if our AI is training on that data, think of all the different points of view that are just based on that data. Oh my God, it's crazy, right? Um, Another thing, is really just the sheer computational ability. Um, and notice that third bullet says, even after employing state-of-the-art hardware like GPUs and the cutting-edge machines and super fast networks and the fastest like video card you can ever dream of owning, right, driving your AI engines, some AI models take months and months to get trained. Like, you get an algorithm running and then you walk away for a couple of months and let it do its work, because it takes that long to crunch the numbers in the code. There's a lot of cost involved with it. The computing power is not cheap, right? So it says here that mining, storing, and analyzing data costs a lot of money. It also burns a lot of energy. It also requires a lot of hardware and trained people to do all of that. It says the training cost of some of the AI models goes up to 2.4 million. I can only imagine with some of the newer cutting edge models that it's even more expensive than that, right? So just to train a model computationally, they might have to pay a data center $2.4 million to train that AI model. And then we use Chat GPT and we're like, hey, what's my favorite color? What should I have for dinner tonight? Right. So goofy little things like that we ask those questions. Um, so the AI models really do need a lot of data to train on. So it says data from different sources varies. Some of it is really good. Some of it is not. You know, do I want to train my AI model on social media feeds or from scientifically researched papers, which would be better? Yeah, easy answer there. It says data collected during surveys are always subject to the bias of the people because people don't always tell the truth. So you might collect data from people and they're not telling you the real deal. Okay, so pretty scary stuff right there. It says we require huge amounts of continuous data to train an AI model, which is sometimes difficult to fetch. So that we have solutions and workarounds for that. And also usually the best data is behind firewalls. It is like behind a login. It's on somebody's private system and they're not giving it up. Right. So like when you guys like go out on the internet and use free services, whatever those free services are, the trade-off is you're giving them information. Think about this. We use the grocery store example. You walk into Pick and Save, right? and then you want to get the sale price on bread or whatever, you got to type in your shopper code or your phone number, right? Or show your pick and save card. And then they give you the sale price. Why? Because you're trading the fact that you're buying, you know, this loaf of bread versus that loaf of bread, and they're tracking that data. You know, all of that is measured. Um, Data sometimes is tightly held onto by organizations. So, for example, like if we keep data on you guys as students, we don't share that with the world. That's against the law, actually, right? But there would be a lot of valuable information in that data for people that want to market to students or sell certain types of products, absolutely. But that data often is protected, right? So sometimes the best data is unavailable to train AI, unfortunately, right? The bias thing is pretty huge. And this is really kind of a disturbing part of it. Like if we're training our AI models on public facing data and we know that data is not good, and we know people lie, and we know people have opinions, and maybe the data that's being presented is being presented to favor one organization or entity or whatever, we get the bias in the mix, and that's really problematic. So then our AI, if it's trained on biased data, might give very biased responses. And that's been one of the biggest complaints about generative AI is it is biased often against people we really don't want it to be biased against. Look at that last bullet. An AI model is 10 times more likely to identify African American male as a criminal as opposed to a non African American male due to the underlying data bias, not because it's actually true. Isn't that horrible? It is absolutely horrible, right? And this is one of the things, like, so when you look at AI content and you're doing it yourself, even, right? Make like a fake image of somebody or whatever. Um, one of our speakers, we had a keynote speaker at our in-service back in fall, and she did a thing on AI, ironically, and she asked an AI engine to show a picture of, you know, I don't know, like a certain type of individual, and it put race and gender bias into the image, and it was highly inappropriate. Like if any of us would have did it, people would call you a racist or a bigot or whatever. But the AI did it because it didn't know any better. That was the data it was trained on. So really big issue. So when you generate content, you look at those aspects of it real closely, right? Over time, this should get better, but if we're training on public facing data, it's not always good data. The time it costs, I mean, okay, do a simple training on an AI model, and notice what it says here. On a traditional PC, it might take a few days to a few months. So like if I have a really large data set, I have a, let's say, an algorithm written in Python that's going to train my machine learning model, and I give it all the data and I let it run the code, it might sit there and cycle for a long time, right? It takes a long time on regular equipment. And here I'll give you kind of a correlational example. In the old days when we used to render video on computers, right? Like when they did like the first Toy Story movie, I think it took them something like an hour per frame or something like that to generate the video. And there's, you know, 24 frames in a second on film, 60 frames per second, um, in a more modern refresh rate. How long it would take to render digital video back in the 90s when those 3D movies, animated ones, first came out. It took forever. Computational power was extreme. Now we can do it on our laptop because our machines are that kind of powerful. Still take us a while, but a lot faster, right? Um, and notice, that second bullet says if there's any errors in the model, if the model's not right, well, then guess what? You're going to have to retrain it again. So then more cost goes in. And this is one of the reasons why it took us so long to get the generative AI models out there. And then once the good models were built, and more importantly, the code that built them was shared, open source code, and other people could build on the same code, then the whole process started to accelerate. couple that with all the technological advances, and it really makes us understand why we're where we're at now. You know, one of the big problems really is, good quality data. And there's a couple things that they've done recently to kind of overcome this. And one of them is this concept of synthetic data. And we're going to talk about this a lot. Um, those of you that may have had the database class with me, right? We talked about this last time too, I think. We got to like, I forget what exercise we were doing towards the end of the course. And I think it was like a dog database, like dog rescue database. And needed to generate some entries for the database. And rather than sit there and imagine dog names and type up, manually to come up with pretend information or research it on the web or gather the information, think of like the task that is. I just went to a generative AI and said, hey, here's the format of my database table. Can you generate like 50 fictitious dogs? And we'll drop it in. And that is, it's not real data. It's synthetic data. But then I could run my database homework and get an output that kind of made sense, right? So what is happening now is we are using generative AI engines more and more often now to create synthetic information that we then use to train our future AI models, right? Like, how weird is that? So we're training our AI models on pretend data. Let's remove some of that bias out of there, that kind of thing. Let's let's look at the data that we already have and make not a replicant of it, but something like that. And we'll use that for more training of our model. This is really kind of a weird thought, right? So we're using synthetic information to train our AIs. Very interesting. And it's not that you should use all synthetic data. You should use some data that's real, but if you can add more data, like basically AI models get trained better with the more data you feed them. So if you can't access the information, what choice do you have aside from generating pretend data to train your AI model, right? If I can't get behind the firewall to get the data, then how am I going to give it good information? There's certain types that you'll learn about all this terminology as we move forward, but we have, like, for example, generative adversarial networks, which basically generate synthetic data, and then they look at the data they just generated and try to figure out if they can tell if it's false or not. Like, is that synthetic or not? And if it doesn't pass its own test, it rejects it and regenerates new data until it looks real to the AI trying to analyze it and use it. Isn't that weird? And that's what they mean by adversarial networks. Really kind of helpful though. And one of the things that, if you don't have access to the data, if you can get synthetic data, and notice that the second bullet, that closely resembles real data, that helps AI systems to be more accurate. So this is one of the reasons why we do it. Better training of AI models ultimately, resolves in better AI performance, or in principle, in better AI performance. All right. This is kind of interesting, right? So they're going to ramp this up now, where we're going to take the synthetic data that we're generating, and we're going to now generate synthetic sensor data. And just to give you an example, like if you guys are ever on campus at Gateway and you walk into a classroom and you sit in the classroom, and we have light switches on the wall and you can turn on your lights that way. But most of us who understand the system there now never turn the lights on and off. We just turn them on, and then they get turned off by the sensors in the room. There's sensors in the room that detect audio and light and movement, right? So if I walk into the room, the lights come on. That's pretty cool, right? I don't know if any of you have those at home. We put that in one of our rooms in the house, in our laundry room, and I wish, really, it would be a smart thing to have in every room, You walk in, turn on the lights, you don't have to worry about it. Who doesn't want the lights on, right? Those classrooms are also equipped with temperature sensors. And when they know the room is empty, the temperature doesn't have to be turned up as high in the winter, or in the summer, it doesn't have to cool as much. And then the sensor will detect when humans walk into the room, and then the heat comes on, right? That kind of stuff makes sense. But if we want to train our AI to do that automatically, like to maybe figure out when to turn the heat on and off, we can look at simulating the data that the sensors in the room are doing. And that's a really primitive example. So here's like modern classroom environments that have all these computer sensors built in, but we also have those kind of sensors out in the world, right? Like if you drive through an intersection, there are traffic sensors, right? Or as a lot of us have figured out, that sometimes they put magnetic sensors in the roadways, so if I pull up to the light and sit on top of the sensor, the light will change, right? Has any of you guys ever figured that out? Right. And one that my wife and I figured out is, what, like, we'll shop at Woodman's, and when we leave, if I pull all the way up to the stoplight and it's really late at night, the light will never change. And then we figured out, if we back up like 10 feet, we figured out where the sensor was, and then it triggers the lights. And I think that's pretty fascinating. A lot of traffic lights now are sensor driven. I think that's really kind of interesting. But if we can simulate that sensor data, it really has a lot of potential in improving our AI models a little bit more rapidly. So let's start to talk about these disruptive technologies. And I like that word, because disruptive, it seems to have like a negative connotation, but truly, is it a bad thing that we all have smartphones now? Like, you could argue, yes, I'm sure. Right. But I think of, like, all right, when I went to school as a child, if, let's say, you got hurt at school and your parents needed to be called, right? You'd have to go to the office. They'd have to look up your parents. They'd have to call the number, and hopefully the number was right, and they could get a hold of them, and they could pick you up. But now, even kids in grade school walk around with smartphones, right? Maybe it's their parents' old phone. And okay, it's kind of disruptive, right? You don't want kids on the phones in the classroom, for sure. But now, if there's an emergency, they can call themselves, right? Or whatever. And there's other aspects to it, but there's all sorts of really big, disruptive technologies. Really, computers themselves were a disruptive technology several decades ago. Then the internet came about. That became a disruptive technology, right? So people who are used to, doing things the old-fashioned way, and finding information, like, I'm going to go to the library and look it up, that kind of thing. And now we just hop up on a computer and Google whatever we want, and we have the information right there. There's a YouTube how-to video that goes with it. You know what I mean? And some of the latest disruptive technologies are the ones we're about to look at on the screen. One of them is 5G, right? And at this point, like, if you're out buying a new phone or trading one in or whatever, swapping one out, all the modern phones are doing 5G now, because that's the cellular networks, right? Why is 5G important? Well, the bandwidth of 5G compared to the previous technologies is significantly higher. Compared to 4G and 3G, man, the data transmission rates are super, super fast. It does operate at a different frequency, so the transmission radiuses aren't as far. So they have to have a lot more 5G towers than the old-fashioned big cell towers. And it's down to the point where those 5G towers, like, if you live in a neighborhood, you probably have several small 5G towers in your neighborhood, and they sit pretty silently on top of, like, phone poles and stuff. And it's really kind of interesting to try to spot them. What a lot of people don't realize about 5G technology is it's not just for cellular use. When the Foxconn Corporation moved into our area and built a factory, they gifted Gateway a 5G, let's call it, network access point that works in the same frequency ranges as the cell phones. It's not the same 5G technology that you have in your Wi-Fi. It's a different 5G technology that runs super high bandwidth technologies. And the reason they gifted it to us was to gather all the wireless sensor data from all the robots at our engineering center and then feed that right into the server rack where we run our data servers for this program. And so we gather the information from the robots wirelessly rather than running wires. And that wireless connection is faster than most of the wires. Right. So super, super fast networks. Now, whether or not you get the full network speed, that's a whole different story. Usually you still have to be close to the tower. You still have to have a good device, et cetera, et cetera. And what you're connecting to has to be fast. Here's a big movement that's happening right now, autonomous vehicles, right? Granted, most of us still drive our cars, but there are states in this union where autonomous vehicles are allowed. So you can go to places like San Francisco and they have self-driving Ubers, right? And they're street legal. I think it's pretty fascinating. Technology has been around for a while. And notice like some of the predictions here, it's going to be a $35 billion market between 2022 and 2030, right? And we're like halfway through that period already. And they're anticipating widespread adoption by 2035. So those of you that have held off on learning how to drive, in 10 years, you won't have to, is what they're trying to tell you, provided you can afford to do it. That's the other aspect of this. But most likely for all of us here in this session are your children, or at least your children's children, will never learn how to drive a car because they won't have to. They'll just get into a vehicle, tell it where you want to go, probably on an app or something, or maybe it'll read your brain at that point and it'll just take you there. Really freaky. A number of years back, I was taken on a trip out to the Tesla plant out in Reno, Nevada. And as part of the visit there, we got a drive in a Tesla vehicle. The guy took us out on the road. He was out on the interstate. And then he turned on the autopilot. And while we were on the interstate, it started talking. He just like let go of the wheel and turned around and started talking to us. And the car was like passing other vehicles, making maneuvers, slowing down, speeding up, all on its own. This is 7-8 years ago, right? And there's a lot of vehicles that have these capabilities built in. I rented a car a couple of years back on a trip. I think it was like a Toyota Camry or something, had automatic lane correction. The cruise control would auto adjust its speed depending on the other traffic. All automatic braking, all that stuff. And I did test it a couple of times on the freeway. I just let go of the wheel and yeah, it would turn and stuff. After a while, it would do this feedback. It would vibrate the steering wheel violently until I grabbed it again. It did not like me letting go completely, but it was capable of driving without me holding it. There's cars that can park themselves. All that stuff is happening already. We'll talk a little bit more about the autonomous vehicle things because we do have some connections at Gateway with some of those things. There's this thing called the Internet of Things. And real classically here, I'm trying to see if I can reach it. I had this goofy little device sitting here, which is kind of a classic Internet of Things device. This is probably very hard for most of you to see. I'm trying to hold it in front of my face so it doesn't filter out. But what I'm holding in my hand here is a Raspberry Pi. And it's not obviously not something I eat. This is a small form factor computer. It's a little bit larger than a credit card, and I bought a little case for it, but basically it's a full-blown computer system that I can hold in the palm of my hand that does everything a normal computer system can do. It's got USB ports and a network port. It's got Bluetooth and Wi-Fi, HDMI, a little power port, audio port. I can plug in a little micro SD card as my hard drive. And it's like these tiny little micro form factor computers that are responsible for this movement called the Internet of Things. And the concept is basically that all sorts of devices, the sensors in the classroom that I was talking about, the temperature sensors and light and sound sensors, have little computers built into them, and they're connected to the network. And We can take devices that used to be um, not computerized and are now connected. Here's an example: a Ring doorbell is an Internet of Things device. And I know many of you might not have that brand, but that's like the popular brand. And somebody walks up to your house, the camera turns on, you can get a little message on your phone, hey, there's somebody at your door, that type of thing. That's an Internet of Things device. The traffic sensors I was talking about, those are Internet of Things devices, a lot of like tiny little devices. Each are all full-blown computers and all connected to the internet. Um, and notice like the numbers here, the number of IoT connected devices projected to increase to 43 billion by 2023. We're in 2026. I wonder what the number is now, right? Um, the fact that we have sensors embedded into everything, and they show, like, for example, like QR codes here, but how many of us use things like tap to pay? There's like little chips in our credit cards now. You know what I mean? Crazy stuff, disruptive technology changing everything. Then we have this thing called big data. And in other words, we have so much information that we're generating. We need to find ways to store it. So what are we doing? We're building more and more data centers and hard drives and computers and power plants, to power it all. And I think one of the reasons they're taking pennies away is because they need the copper to build more computers, right? Not because they don't want to use pennies anymore, but partially because of that too. Um, it says here, big data is expected to increase the revenue of healthcare, transportation, and retail sectors by up to $150 billion because they can store the information that they weren't able to store before. It is a huge factor, though. It is very expensive ultimately, but it will have a big impact on society for sure. A couple of questions they throw in here. You can contemplate these on your own. But think about this, right? If you were to take away some of the disruptive technologies that we already are used to, and I'm thinking like the internet and our cell phones, what would your world look like without those two technologies? And where we're moving with this ones that we just mentioned, and notice 5G, all right, that's kind of fully in play. Autonomous vehicles are kind of there already. Internet of Things is there, big data. These are disruptive technologies that as we move into the future, without these, society will arguably perhaps not operate all that well. Let's talk about the autonomous vehicle thing here. And this is a really pretty fascinating area because it's kind of like not a new concept once again. And I think this is kind of interesting. So they have like these goofy things here where they point out some movies historically. And of course, in my era, it was Herbie the Love Bug, right? That was like a car you could talk to and it had a personality and it would like wink its lights at you and goofy stuff like that. And then Batman had the Batmobile that was kind of sort of like that too. And then if you watch like the Avengers films, Iron Man had his car, if you guys remember all that, right? And they talk about it in terms of like eras. And when they looked at like basically like the first ideas of it, there wasn't really a computer behind the scene. They just kind of like had, oh no, this car is like supernaturally empowered by the spirit of Herbie, right? There wasn't like this AI engine inside of it. It was kind of like magical, you know. Then when we started to look at more of like the modern sci-fi movies, they really started to look at like, notice some of the movies here, Batman from 1989 and Time Cop from 94 and The Fifth Element from 97. I don't know if you guys saw any of those movies, but they're all worth a watch. They had vehicles that were self-driving or had an intelligence, but it was definitely computer based, right? So they kind of imagined this concept that a car eventually could do that. Interestingly, and you think about this, if you get on an airplane, the pilots do the takeoff, and then they plot a course. And often when they're up in the air, there's an autopilot on the plane that steers the plane and keeps it at a certain height and speed and all that stuff. But people thought about doing that with vehicles all the way back into the 20s. In fact, this guy Houdini, not the magician, different Houdini, made that attempt to put a radio control into a car. And I don't know if any of you guys have ever done like little RC cars or anything like that. It's a thing, right? You can remote control by radio little gas powered vehicles or battery powered vehicles, and it's a kind of like a whole thing that people get into. But he actually had a primitive but working radio car back in the 20s, right, to remote control a car with a radio. So not really a completely new thought. All right, but when we think about the concept of autonomous vehicle, that really is on a slightly different level. Let's go ahead and let me see if I can get this video to play here.
With automated driving, we're taking our core capabilities of visual understanding to the next level, where the degree of details required to support self-driving cars grows by leaps and bounds. In addition to preventing collisions, the system must sense the road at great details, including lane markings, curbs, barriers, obstructions, recognize a large vocabulary of traffic signs and traffic lights, and be fault tolerant to a degree unparalleled by today's driver assistance systems. But the greatest challenge is to have it done at cost levels that drivers can afford. Many studies have shown that customers interested in hands-free driving capabilities but are also very sensitive to costs. Cameras are low cost and generate a very rich source of information about the scene. The challenge is to extract from the raw data the information of interest, but this is our core competence. We have introduced visual understanding functions for active safety that no one before us managed to do. We have full confidence that we can take the next step and be part of a real revolution in the way we drive.
Right, and I'm going to cap it right there, but you guys get the idea here that there are technologies out there already that can do this, and the first time you are exposed to it, it is a freaky thing, right? For sure, but it is coming, and I think that they're correctly identifying the fact that cost is really a big issue, right? I mean, buying a really nice car is already a big issue for most people. Most people can't afford to buy a brand new $60,000 car. If the autonomous version costs another 30 or 40 grand, are you gonna do that? Yeah, and then you get in an accident and the thing's totaled. Yeah, I mean it's a lot of money, so that's a big barrier right now. But they talk about a fully autonomous car that would be self-aware, making its own choices. And I want you to notice here that there's these different levels, right? And this is a self-driving car can drive itself in some or even all situations, but a human passenger must always be present and ready to take control. And then if you take this graphic here, I'm going to just enlarge it so we can kind of read it a little bit better. But notice here that they talk about, all right, what we do now for most of us is just manual control. We get in the car, turn the key, and we drive, right? There's no automatic braking or any of that kind of stuff, right? There's driver assistance, and that's kind of what I had, maybe a 1 or a 2 level on that Toyota Camry, where it would correct lanes for me a little bit, or if I got the cruise control on and I'm getting too close to somebody, it would slow me down, that type of thing. And then we get up to this like level 3 thing where it's into the automation area, and this is one of those really key words when we work with AI stuff, is talking about this word automation, right? And it says environmental detection capabilities. The vehicle can perform most driving tasks, but human override is still required. Probably like parallel parking, or maybe if it's snowy out and slippery, that kind of thing. High automation, the vehicle does all the driving tasks under certain circumstances. Geofencing is required, right? We don't even know what that is yet. And human override is still an option. And geofencing is basically Like if any of you guys have ever got one of those like wireless dog collar things where you put these like sensors in your yard and you put the collar on your dog. If he tries to walk out of the yard, it buzzes his neck, that kind of thing. That's geofencing. So what they're saying is that we have to have our roadways set up for it. So we might have to put sensors that the autonomous vehicles can pick up and drive themselves. And right now, a lot of them use cameras and look at lane markings. But if you've ever driven on a Wisconsin road after a snowstorm and the lane markings are worn off because the plow destroyed them or something, what happens then? Have you ever been on a freeway where you can't see the lane markers? Yeah, it's problematic. Um, and then we go to zero or zero human intervention, which is full automation, where the vehicle can just do everything. You don't have to tell it to do a darn thing. And I think that's really kind of an interesting concept. So autonomous vehicles use a lot of different technologies to figure out where they're going. All right. So they're saying sensors, actuators, all these algorithms that they're trained on. There's machine learning. And then you have tons of really high-end computers driving the whole thing. Right. Now, I'm using a pretty good computer here, but in the last class, it crashed mid-class and I had to reboot and restart the Zoom session. So computers can fail. So what happens if you're on the highway and your computer locks up? Right. That's not a scenario you want to think about. But notice that it says they can create and maintain a map of their surroundings based on a variety of sensors. They monitor nearby vehicles, they look at traffic lights, read road signs, track other vehicles, look for pedestrians, right? Those are all things that those autonomous vehicles do. All right. I'm going to run this video here also. And I think this is kind of an enlightening one. So we'll just watch a bit of this. Did you notice the guy was mid-turn and then it noticed the car coming through and stopped? Be able to pass a bus, change lanes on the freeway, all of that. Very cool. And as it goes through this video here, and I'm going to let you guys watch the rest of this on your own, it goes into increasingly more complex traffic situations. And what this shows you, and mind you, this is a dated video. It's a few years old. They've got this technology pretty well figured out already. It really largely is who can afford it. That is probably the biggest barrier, right? And let's also mention the fact that, like, in some places, it's not legal. So I'm not sure if, I know for a fact California is legal with autonomous vehicles, but they have their issues there too. I think one of the things that I think that's pretty fascinating is the fact that autonomous vehicles still do need to be trained to drive. Like, they have algorithms, right? But you have to apply it to the actual vehicle and the actual situation. And one of the things they do to train autonomous vehicles is they come up with fictitious situations and then fictitiously drive the cars through those situations, like basically using synthetic data to train their AI cars, right? Because they don't want to smash the car, like it might smash in the video game version, the synthetic version of it, but it's not going to crash in the real version, right? You don't want that to happen. But think about the stuff that it has to think about, right? So the Gen AI will create a simulated safe simulation. but you can give it weird situations that might happen in the real world. And any of you that have ever been driving or been in an accident or a situation in a car, stuff happens in cars. Maybe not by you, but by the other people on the road or the weather or heck, acts of God, who knows, right? Um, and so they can simulate weird driving situations, dangerous ones. And they can also throw in things like simulated pedestrians and whatever to see how it drives. I think what's fascinating, um, and they show this scenario here, right? The guy's like driving through the intersection, and there comes somebody unexpectedly, like, oh my God, what happens? And um, you can never predict what the other person's going to do. You don't know if they're going to blow the light or even if they even saw the light. And then what happens here? Did this car stop? We really don't know. Right? This is a very iffy type of situation. I think they have this technology that they've been using. This is an NVIDIA technology that they try to throw the most difficult situations at training these models so that when it happens for real, they know what to do. And one of the classic scenarios, right? Like you think about this, you're driving down the road and you can't escape whatever scenario you're in. And one way or the other, you're going to either like run into a tree and probably kill yourself, or you're going to hit the old lady on the street, or you might run over the mom with her kid in the stroller. And which scenario do you choose? You probably don't want to kill yourself. So what, you take out the old lady because they live long enough, or that mom and kid don't have a chance, they may as well take them out now. These are the kinds of like weird things that they try to simulate, and ideally, hopefully, would never have to encounter. I think it's really fascinating, and a lot of people don't know this, but here in Racine, and I think I have one of the slideshows here, they've been working on this for a while, right? And I think they've now abandoned this project because it's really costly, but they were building the Racine Badger, and this is a fully autonomous electric self-driving minibus. And one of the visions that the people in Racine administration of the mayor and people had was that they would try to get a bunch of these out there. So instead of having a big giant bus that nobody rides, they'd have a bunch of these little ones that go on smaller pathways. And this is an actual vehicle, and it is housed at the downtown Racine campus on the first floor in the technical building. And it is filled with a bunch of really cool technologies. It is completely self-driving, but somebody has to be sitting in the driver's seat that can take over. I think it's got room for 6 or 8 passengers, something like that. It's got solar power. It's got LiDAR, cameras, sensors, and a bunch of other stuff built into it. For a while, they were running it on the Lake Road, I think up 6th or 5th Street, back down Main Street, and then back down to the lake on 9th Street or something like that. And it would make that circuit. What you're seeing here is a dump of some of the sensor data. So it has cameras that see the world like this and have LiDAR, which basically bounces out light and receives it back so they can figure out where objects and impediments are. And as it's driving, all the sensors on the vehicle are capturing data. And then that little drive, which is maybe like 10 blocks long around the campus and back, that one little short trip generates 100 megabytes of text-based numeric data from that like 3-minute drive, one little trip. So you can imagine the processing it takes to deal with that information. Here's a picture of it when they did the big press release and they had a news conference at the Racine campus, but this is an actual vehicle. If you look really closely at it, and I know this is not an ideal format to look at it, but there's cameras here. LiDAR sensors in multiple spots. Um, I never took a trip in it personally, but everybody in our admin did, and it was quite a thing. And you can tell this is during the pandemic when they were, because everybody's wearing masks, and now it looks like some like weird science fiction movie or something. But yeah, so that was happening here in the city of Racine. Eventually, I think they wanted to give up this vehicle format, and they were just going to go to standard size vans instead. And I don't know if those are electric or not. This was electric. Um, I think they had some issues with it being an electric vehicle or a regular vehicle. So I'm not sure if they're continuing this plan or not. But they were doing this in partnership with the UW Madison, this private autonomous vehicle company, and the city of Racine were all partnered up on that particular endeavor. All right, folks, I think we're just about at a logical stopping point here. And so what I'm going to do is I'm going to hit a couple more slides and then we'll take a break. So, all right, so talked about our autonomous vehicles, how Gen AI and synthetic data can help train them, having simulated scenarios for vehicles to go through rather than like actually crashing into something in the real world. And I think we talked about all these slides, so I'm kind of like repeating them, so I apologize. Right, I think this is where the new data comes in. So generative AI has been used a lot to do the synthetic data that we need to do the training on these. And the hope is, right, by doing some of the like synthetic like accident situations or driving situations, that we can minimize the amount of training it takes ultimately to actually deploy these. All right. This video here, and this is actually a video, it's an interactive website. If you guys want to check this out, I'm not really going to put this up on screen here, but they talk about some of the vehicles, in these automated garages, and pretty cool to check out. Kind of an interesting website. Right now, we are going to actually take our 5-minute break, so I'll see you guys at about 9:01. So we're just going to do a really quick little 5-minute break, and then we'll come back and resume. So I'll see you guys then. I will pause the video for now, and I'll see you in 5. All right, we're going to focus our attention now on the IoT stuff. And this is kind of interesting too. And I'm going to run their video here for just a moment so you guys can get a little background. I think I talked a little bit about what IoT is, and this is Intel's little video on it.
By now, you may have heard the term Internet of Things. Sounds interesting, but what does the Internet of Things actually mean? IoT is an evolution of mobile, home, and embedded applications that are being connected to the Internet, integrating greater compute capabilities and using data analytics to extract meaningful information. Billions of devices will be connected to the Internet, and soon, hundreds of billions of devices. As related devices connect with each other, they can become an intelligent system of systems. And when these intelligent devices and systems of systems share data over the cloud and analyze it, they can transform our businesses, our lives, and our world in countless ways. Whether it's improving medical outcomes, creating better products faster with lower development costs, making shopping more enjoyable, or optimizing energy generation and consumption. Here's an example of the big picture. Imagine an intelligent device such as a smart traffic camera. The camera can monitor the road for congestion, accidents, and weather conditions, and communicate that status to a gateway that combines it with data from other cameras, creating an intelligent citywide traffic system. Now, imagine that intelligent traffic system connected to other citywide transportation systems, which get data from their own intelligent devices, creating an ever larger intelligent system of systems. The really big possibilities come from analyzing the end-to-end data across that system of systems. For example, let's say the city's intelligent traffic system detects massive congestion due to an accident. That insight can be sent to the citywide transportation system, which can analyze the accident's impact on other city systems. Recognizing the accident is near the airport and 2 city schools, it could notify those systems so they can adjust flight and school schedules. It can also analyze and derive optimal routes around the accident and send those instructions to the city's digital signage system to guide drivers around the accident. And that's just one example of the potential benefits that can happen when intelligent devices share insight with other systems, forming ever-expanding systems of systems.
All right, and I'm going to cap it right there. And you guys, as with all of these, videos and stuff that are embedded in here, there, and I don't always play all of them. You guys are welcome to explore them, and often they will throw additional resources into these PowerPoints, and sometimes they'll be down in the notes section here. This one doesn't have any, but just be mindful of that as you go through these PowerPoints. All right, so going back to this whole IoT thing, and the IoT thing's been happening for quite a while now. But it really is a collection of mini computing devices, and often with software attached to them, and then all of them are connected together and then feed all their data and stuff into bigger systems, which are then used to control other things. And for example, they talk about the physical components, right? So the machine parts, basically. So engines and refrigerators and air conditioners and things like that. And then we also have the computing components inside of them, right? So you might have a washing machine, but does your washing machine have a computer inside of it, right? And what is that a good thing that it does or a bad thing that it does? Well, a lot of modern ones do, but really basic ones. But look at the concept of the Ring doorbell, right? Where really truly that thing is really like a little computer system sitting there. And notice that they start talking about the things that it enables, like smart cars and motion activated cameras and blood sugar sensors and things. Heck, even our smartwatches, might fit into that category, I think. And then you have all the connectivity, right? Whether a connection is wired, but really a lot of IoT stuff is done with wireless devices, which I think is pretty interesting. All of our traffic systems, like next time you guys pull up to an intersection that's got lights, and look up at the lights and look at all the different cameras, sensors, and different things that they have there. And then they'll have a whole wiring closet on the corner somewhere that runs it all, and it's all interconnected to all the sensors. Really kind of crazy. But also we have sensors all over the place, and it's not just at intersections, where they monitor things in real time, and I think that's pretty fascinating as well. And normally we would do these discussions, but in the interest of time, I'm going to be moving along here. All right. So they're trying to give you kind of this analogy here where with IoT devices, one of the things that makes them super powerful is not maybe any one individual device, but connecting them all together. And really, for example, if you have a sensor in one spot that's indicating a problem, it can backfeed the information into the network and forward it through the network and share it with the other points on the network, and therefore take action to kind of rectify the problems in advance. So for example, if there's an accident in one intersection and the previous intersection lights can be controlled by virtue of the fact that the other intersection knows that it had an accident, it can backfeed the information and maybe make that red light a little bit longer just to give time for the situation to clear, that type of thing. Once again, the networking aspect of it is pretty important. Normally, the connectivity on many of these devices, will vary. And I did mention the wired and the wireless. So in a way, they kind of think of these IoT networks as sort of like a social network for devices. I don't know if I necessarily agree with that analogy, but that's the one that they're using here. So we'll just roll with it. So here's kind of a thought, and we're not actually going to do this activity, but a lot of us, like when we get in our cars and go somewhere, we often pull out like our maps app or our GPS app of whatever type we have. And isn't it amazing that like if you plot a route somewhere, it can tell you how long it's going to take. And how do they know that? Well, because the map applications are reading all the traffic sensor data in that network. And then in many cases, even if you're on a route, it can reroute you around a problem that might crop up after you first plotted your route. And if you guys have ever used the GPS and it's rerouted you, that's often what's happening, right? And you have that thing. So like they say, like, take out your phone, plot a route to somewhere, and then they ask you like these goofy questions, like how long does it take to get there, right? A pretty basic question. Um, but they use all these network of devices, and the traffic networks are really pretty impressive. Now, granted, going down the side street in your neighborhood, you're not going to have these sensors. But if you're out on the main road or the highway or like a numbered or main route or whatever, there's tons of them everywhere, and they are monitored, right? With all sorts of things. In many cases, by the way, they're not just camera driven; they're also sensor driven. You can There's ways where you can tap into the camera network. Some of the traffic places allow you to tap in and look at the cameras in real time. Right? It's all out there, and I think that's pretty fascinating that they do that. But the fact that they also monitor the traffic in real time, and then when you run your GPS app and it tries to route you, um, it looks at a bunch of different things. Like if you're traveling at a reasonable rate of speed, it can look at your speed to figure out how long it's going to take to get there. It's like, oh, you're driving really slow, it's going to take you a little bit longer. But it's also looking at the congestion on the route and the speed of the other cars, and are there any accidents reported along the route. And when you have like a good GPS app, and I'm not trying to like promote one or another, they will often tell you things like that, like, hey, there's an accident up ahead, or there's a slowdown up ahead, or there's a police officer up ahead. You might want to slow down, that kind of thing. It makes you all aware of it. But this is one of those things that really is driven by all that, those sensor networks. And then, also, like if you like, well, you know what, this GPS doesn't know better. I know how to get there better than this GPS does, right? You have that kind of attitude and you create your own alternate route. Well, that gets fed back into the network too. So it starts to figure out what the good alternate routes are based upon, the routes that aren't good right now. So I think it's really kind of a fascinating technology, one that we use a lot and really kind of take for granted. Um, you know, how many of you always use the GPS? There's a lot of people now that are like, well, I'm going home. They just hit the button on their phone and it takes you there, right? And you know, and I realize sometimes, hey, I know how to get home. I don't need the GPS, but sometimes I turn it on just so I know, like, okay, there might be police on the highway, so hey, this will tell me where the police are, just for that alone, right? Not that I was speeding, but hey, I want to know, why not? All right. So let's move on then to the 5G technology. And this is kind of an interesting slide because they have headlines from the future. If you guys want to read these are kind of interesting, but they're all dated in 2030 with like imagined scenarios, right? Um, Now, what about this? Like, you get a package delivered to your house and you're not there to sign for it. So what happens? Well, some people just leave it there. And maybe if it's a signature required kind of thing. But what if you had a system at home where you could tell that, hey, there's the delivery guy. Oh, he's at my door right now. He's ringing the bell, and you just come up on the speaker and say, okay, can you leave it in that leave it over there behind the bush or something like that, right? And I don't know if that's really augmented reality. But what is augmented reality? We call it AR. We know what virtual reality is, right? Where we have a completely simulated world. But an augmented reality is where we have an overlay on reality that takes computer information and basically overlays it over what we see. So, like if you ever used Google Glass, right? And I don't think any of us probably have because they're really expensive. But some of those capabilities, like if you go into Street View on Google Maps, you can go into AR mode and you can take your phone when you're on the street and point it at something and it'll give you information about it. Well, I know a lot of people don't use this feature, but it is there on your phones. It's already kind of there. Kind of interesting. They talk about here the breakthrough in human to machine communication. And so, for example, you walk into a restaurant, you sit down at a table, and your food comes, and you're like, you make a face because it's like, oh, this looks terrible. What if they had like or basically facial recognition technology at the restaurant that would recognize it? So, hey, the person at table 5 is making a face about their food. You should go check on it. Maybe there's something wrong with it. Maybe it's not the right food. That type of thing. So, and this is kind of a weird. The last ones are particularly weird, right? There's this whole new thing of using AI as kind of like your, a companion of sorts, right? A lot of people use it in those kinds of ways, but people are applying avatars to that, and what they're indicating here in this fictitious article is that what if somebody was able to hack into that and control it, basically? Kind of an interesting thought, right? Maybe a good reason not to to use it. 5G is a pretty transformative technology. They do not have it deployed everywhere yet. There's still large swaths of the country that do not have wide 5G. Typically in urban areas and in most of southeastern Wisconsin, if you're in a populated area, will have 5G at this point, right? And we're pretty well wired in this area. But if you step out into the country, a lot of people don't have that, right? So I think it will have a big impact. The bandwidth part of it in particular. This video here talks about how they envision 5G having an impact on society. I'm not going to run that video in the interest of time, by the way. But this has been a technology that has been in the plans for a long time, but to deploy it has been a little bit more difficult than the previous technologies. And the general reason is why the old technologies would use one big tower and they could put like all the old, 3G, 4G, and preceding technologies on a big tower, and they could broadcast over great distances. 5G has a very limited transmission radius, so they have to build lots and lots of new towers. So one of the reasons why it's slow to deploy is because of that. It is cheaper to deploy though, because they can often just put it on top of a street light or a phone pole or something like that that's already in your neighborhood. They don't have to build a brand new tower to do it, but they have to have a lot more accessibility points in the network to allow for it. The bandwidth that it brings is transformative for a lot of people. A lot of people, for example, who live in 5G areas now are giving up their old internet service providers like, Spectrum and AT&T, where they run wires to your house, and are now just using cellular hotspots that run on the 5G network and are faster than the stuff that was wired that we were using before. Does anybody here do internet like that? Nobody? Not one? Okay. A lot of people are switching to it. So I'm hearing from more and more people that are doing it and really, really like it, by the way. Of course, our phones often do it too, right? Yeah, so it's anticipated that it's going to add a lot of value to the economy is one of the things that they're doing here. And some of the things, that the questions that we have about this tech will be answered in this video here. So I'm gonna run a little bit of it. Let's check it out.
5G. It promises to transform our lives in all kinds of different ways. But what is it exactly? It's often described as just the next step in the pursuit of an ever faster network. But in reality, 5G is much, much more. It's an entirely new technological foundation, purpose-built to support the next great wave of life-changing digital advancements that will be enabled by our smart and connected future. From the safety and environmental benefits of autonomous driving, to dramatic breakthroughs in artificial intelligence via machine learning, and a whole new era in healthcare, to a smart and connected revolution that will transform agriculture, manufacturing, cities, and our individual homes. Even virtual and augmented reality. Every one of these promising new breakthroughs will be built on the common foundation of 5G, enabling billions of things to be made smart through seamless connectivity, massive computing power, and access to rich data and analytics stored at the eye of the cloud. All of which means one company is uniquely positioned to power 5G.
A little bit of a commercial for Intel there, but when the technology was first being developed, they were trying to really envision why it's really that much different, and really it is, right? So if you start to look into the differences between like the previous technology and the current technology, it really is significantly faster. It has way less latency, much faster transmission rates. It uses less power, etc. There are people that are concerned with the technology too, though. They think that it causes harm, so there is that aspect of it too. But the real big thing is really all these low latency services. So for example, if you had a self-driving car, what network do you want it on, right? If it's doing network communications or internet communications, do you want it pulling its driving data from the 4G network, which might be slow, or a 5G network, which is going to be 10 times faster, or whatever it is? And what they're showing you here in this little chart basically is a chart that shows on the one side, the left side here, the latency, right? So latency is like kind of the wait period between when an action is initiated and it actually happens or appears to happen to the person on the receiving end. So for example, like in the old days when we would do these Zoom calls, and the networks were a lot slower, I would see like, hey, how's it going? You would hear it a half second later, then you would respond, and I would hear it. So like, and be like, oh, okay, I'm fine. So it'd be like, hey, how's it going? I'm good. It was like there's that wait period just because the network was slow. So when we look at latency, 1,000 milliseconds is one whole second. Doesn't seem like a lot of time, but if you're driving a car and you're about to get in an accident, a lot can happen in a second. Like split second timing is important. And so they show you all the things that are possible, basically when the latency is removed or minimized, right? When you think of like a really good example, right? Look, gamers get this, right? Because you try to play a network game and you're always looking for the server that's got the least latency, right? Because that way when you shoot somebody or do something in that environment, it happens that much faster. You don't want a 1 second latency, that would be horrible, right? So there will be a really huge impact, right? The combo really of all this Gen AI coming out, hitting at the same time as 5G, where we have better networks. Holy cow, it really enables it to happen. And look at all the different things that, will be benefited by the combination of those two technologies. And I think it's interesting. Here's one of those slides, right? 2/3 of the world's data didn't exist 5 years ago, and the data sphere will grow by more than 5 times by 2025. And this is a slideshow from 2023, right? So we're already there. So how much more is it going to grow? Yeah. And man, AI is really, really taken off, the generative AI in particular. Um, yeah, the rollout cost is high because they have to put up a lot more infrastructure than they had before. It's a lot more wiring, and they need a lot more access points to make it happen. Um, yeah, and notice that second bullet. While 5G might bring about real connectivity for predominantly urban areas, those in rural settings will not benefit, right? Because if you have to have a 5G access point all over the place, like in our neighborhood here, where it's like maybe a 4 block by 5 block area, we have 2 or 3 5G towers in our neighborhood. But we have a bunch of people that live here. There's hundreds, or if not 1,000 people living in our neighborhood. Go out into the country, there's not really a lot of financial incentive to put 5G everywhere, right? So and they can't put up big towers that are 5G because that can be harmful if the signal's too strong, right? So you got all those issues. Right right now, they say it's in research and development. No, it's fully deployed. It's been deployed for a couple of years now. And now we're at the point too where 5G is ramping up. I don't know if there's a 6G coming. I think it'll be a long, long ways out. But the bandwidth of 5G will be here for a while, and we don't fully utilize the bandwidth of it already, right? So there's a lot of room for growth on that platform. When you start to combine all these technologies together, and this is really where it gets powerful, is the combination of the data and the IoT and the 5G and all of those things working together. We can use the tech then, right? If we can take our generative AI and we can apply it to handle all that data that's being generated, now we have some true insights that can happen. We can come up with brand new ways to do things. And in fact, coders are learning that AI is a companion when they're writing computer code, right? To help accelerate their workflow, to come up with new ideas, to streamline the process of creating something new. And if we can increase the rate of creating something new, maybe the rate of creating something new and potentially societally transformative in a positive way can happen faster too, right? So use the AI to create good things, not have it cure hunger and disease and and all those kind of things, right? When we start to apply AI over some of these networks, right? So Gen AI can start to impact the network itself, where we can find faster ways to route the traffic, for example, or to protect it from cyber attacks. And that's a really big thing in cybersecurity right now, is starting to use AI to defend our networks. I just learned that recently that Gateway put in a new security appliance that is AI driven. And so if they find out like a new attack point on the internet, like a group of hackers or whatever, they have the firewall at school automatically adapts to it, right? We don't have to have a tech that programs it. The AI learns it and then incorporates it into its firewall rules. In principle, if they're improving the networks with this technology, it should make it cheaper. It should also make it more accessible. And you know what? I got a new cell phone a few months back, and I did for the first time in a long time, didn't get a flagship phone. I got like a budget model, and I'm so happy with it. It really is pretty good, and it's super fast. I wonder how good the real ones are, but it is on a 5G network, and I do notice the difference. I use my device now more for data connections that I did in the past, including like tethering my technology off of it, like my laptops and other devices. All right, hopefully, and these are some of the imaginations of some of these technologies, when we can use them in positive ways, that we can create a better future. Really, truly, that's kind of the vision. I also caution people. It's like when you envision the future, envision a good future, because don't envision a bad one, because it might come to be a bad one. So I'm pretty excited for some of the things that can happen with this technology, but I think we also have to proceed with extreme caution. Generative AI in particular. So for all of us that are using it for either fun things or productive and positive things, there's also a group of people out there that are using it for nefarious purposes as well. So if we're using AI to protect our networks, people are also using AI to try to infiltrate networks and to do hacking and to destroy things, right? So there's that faction as well. So this is of concern for sure. Just kind of leave you with these thoughts here. We're just about to wrap up, folks. So a couple closing thoughts. So here the one thought is, how did generative AI become the modern day Big Bang, right? I look at like the bullets that they put here, and I think this is kind of interesting. One of the biggest changes to the internet after social media and crypto has been AI. Now you jump onto your browser, and I'll have you think about this, and you do a Google search, and now we all get AI search results. So we don't even scroll down and look at the search results anymore. We just read what the AI gives us and goes, oh, it says right here, it's this. So I don't even need to click on the link and go to the web page. That's great, unless you're the website owner that you were hoping to get the clicks so people will come to your website and buy your products. Now that person's not making a sale, right? So kind of an interesting thought. They are giving it out for free. They don't give it out completely free, right? And like if you use some of the AI engines, you do run into usage walls. And I think I asked this last time. Do any of you here subscribe to any of the engines? Teofilo? Okay. Can I ask which one you subscribe to?
Gemini.
Okay. And, by the way, we're all Gemini subscribers here at Gateway. So if you access Gemini through your Gateway account, you have an expanded usage of it. Copilot also is built into the Office 365 to some degree. The ones that people do, more popular engines like ChatGPT do have a monthly subscription. And if any of you use those, and I use them on occasion for code generation and helping me pull materials together and things like that, you can reach usage walls, right? Like, oh, yeah, you use up all your credits for the day, come back tomorrow, right? And that gets really frustrating, especially if you're on a roll getting work done. But yeah, it is, a lot of it is available for free. And if you don't use it a lot, there's no reason why you have to pay. And one of the strategies a lot of people use for AI engines is you use one engine, maybe exhaust your daily credits, move to a different one, but you also discover when you start to try different tools that they have different qualities of output for different types of content. Some of the big AI companies, so these are some of the parent companies that create these technologies. So Jasper did 100 million in revenue, valued at 1.5 billion. OpenAI, tens of billions of dollars. That might even be conservative. OpenAI is the company that creates ChatGPT. And then you have Anthropic, which is the company that created Claude, right? And Claude is kind of the one that a lot of coders use, by the way. Lots of interest. A lot of people are investing in it. When they were putting these slides together, the investments were going in. There's a lot of people freaking out, thinking there's going to be an AI bubble. Oh, I see. Yeah, right. And Teofilo puts a good thing in the chat there that you can use the pro version 1 year for free, right? They want to hook you on it, right? And Gemini is all right. I think it's getting better, but I have some little nitpicky things about it I don't like. Like if I ask it to create, like, for example, a Word document, it won't do it. It'll give me a PDF, not a Word document, or give me an Excel spreadsheet, and it won't do that either. It's a little like company fighting within the engines. Um, yeah, I think this is kind of interesting. They talk about the speed of transformation, um, and people have been working on these problems now. I want, mind you, since basically the 50s, or they've been conceptualizing them and thinking about them. There were some really big moments in AI development, right? So, like back in the 90s, they had IBM's AI, Deep Blue, went up against a chess champion and beat him, right? That was 97. And then there's this other game that's more complex than Czech called Go, or AlphaGo, whatever. I don't know if you guys know that game or not. And that one um, supposedly is got like I don't know how many permutations you can do compared to chess. It's way more complicated and almost impossible to master. Beat like the preeminent master back in 2016, and now we're in 2026. So what can AI do now? Yeah, I'm not really sure, but it's going to go to crazy levels. Um, there's been a lot of advancements in the AI models. Just even within the last couple of years, we've gone from chat GPT 2 to 3 to 4, and now we're on 5, and it keeps going, folks. And then as each new model comes up, you know, they, and think about this, they use the new models to build the new models that are coming, right? And to accelerate the training growth of them. We also are starting to see some vastly improved computing technology coming out. So it's not just the 5G connectivity, and now that we're starting to get like fiber to the home and super high internet speeds, but it's also things like the graphics cards and GPUs and CPUs that they're building to power these things. And it's kind of weird to think that a lot of GPUs, especially the super powerful ones, aren't going into gaming systems. They're going into AI data centers. And I think that's really pretty fascinating. One little interesting thing that a lot of people don't know is the kind of like the preferred GPUs for doing AI work are the ones that NVIDIA is producing. And the guy who built that company went to school here in Milwaukee at the Milwaukee School of Engineering. Did you guys know that? And a lot of people don't know that. So we have a lot of connections to these powerful technologies here in Wisconsin. Anyhow, we'll see that continue into the future for sure. Some discussion questions here that I'm going to skip over, and then the bibliography page here at the end. So that basically wraps all the material. So I'm going to stop the video here.